Welcome to Unit 4. Now it's finally time to start solving problems. We've gone through in Units 2 and 3 a process of collecting data and then using that data to identify and better understand our problems. However, that doesn't stop once we begin to create our solutions. Creating solutions involves continuously returning to the data and returning to the stakeholders involved to make sure that the solution you're designing is actually solving the problems that you've identified. A key difference in design thinking versus more traditional design processes is that in design thinking, you are designing with your audience versus traditional design processes where you're designing, coming in as the expert and designing for them. The people who you're designing with are constantly in the process. They're at the table. They are helping draft solutions and then helping provide feedback. Two key principles in design thinking that differentiate it from traditional design processes are the fact that design thinking is much more iterative in nature. Basically, in a design thinking process, you're going to create something, then take it back to the stakeholders and collect more data about the effectiveness of that potential solution and make tweaks as you go. The second key differentiator in design thinking is that design thinking solutions are supposed to be human-centered. You're designing for the people who will be actually using your solution. Therefore, it's important that you have them at the table the whole way through, that you're collecting data from them as you go through the process of creating your solution, and that your solution is tailored to their specific needs. Consider, for example, classroom furniture. The needs of students in a 3rd grade art classroom and an 8th grade science classroom are going to be much different. So accounting for what the user needs is going to be essential for creating furniture that is useful to them in their classrooms. One of the tools that we use when creating solutions is we will create algorithms. Traditionally, when we think of algorithms, we think of computer science, but an algorithm is really just a way of breaking down a procedure in a way that is step-by-step so that it's easily and consistently reproducible by either a person or a machine. We do this in everyday life all the time. We can, in the classroom, you'll see it in long division or classifying rocks or writing a 5-paragraph essay. At home, you'll see this whenever you make a cup of coffee or a sandwich. At the core, an algorithm is simply a way of defining a problem for reproducibility. We'll hear a little bit about algorithms and human-centered designs from our practitioners.
In medicine, it's all patient-centered, right? That's the whole goal, is to be patient-centered, to find the right therapy for that patient. So not only do you have to make a diagnosis, and then you have to propose a therapy, but you have to propose a therapy that works for that patient, right? So for some patients, surgery is not a good solution. For others, chemotherapy is not a good solution. For others, antibiotics are a terrible thing and they don't ever want to take them. And all of that has to be taken into consideration. And as you are collecting data during the patient interaction, and as you're coming up with a diagnosis, at the same time, you're reading the patient that you're dealing with, and you're figuring out, what's my best way of interacting with this person? So I know what the data is on the outcomes, and what I would like for them to do is have their best possible outcome. So what do they want? And sometimes the question is as simply as, hey, I have 2 different ways we can go here. Which one sounds good to you? Which one's going to make you feel the most comfortable? The outcomes are pretty similar. Or, you know what, I know that you're 93 years old, and really the only thing you care about is making it to your granddaughter's wedding next month, right? So how do we get you there? So the human side and the patient-centered side of medicine is very real. And coordinating that with the data side is the art of medicine.
Depending on how heavy the project is and how out of my own realm I am, it involves a lot of collaboration and a lot of ideation. The most important stakeholder is the user, whoever's going to be benefiting most from it from a day-to-day standpoint, as opposed to just like the owner of the building or the owner of the plot. the most important person for me is the user. So in my field particularly, there's a lot of community engagement, a lot of getting feedback on that idea, and then running that by community members after a certain point. So after a certain amount of ideation, bring them a schematic idea or a plan. And maybe that also has a community design workshop where you bring in different options and have them look at it and have them improve it or suggest new things, or just a lot of collaboration over and over and over again. It's this never-ending loop of collaboration, ideation, working it out, and then having an idea at the end that actually makes sense and is feasible and can be implemented.
So many times what happens is it looks great on paper. It looks great when you run it through a software, but is it constructible? Is it economically feasible? Some of the alternatives, even though it looks great at the surface, only when you start digging in, you would realize that you would be impacting a major section of the population residing in that area, which makes it impossible to build a particular alternative. So yes, we go through a lot of iterations, and that's why we develop a set of wide range of alternatives that covers the different areas. We get a lot of feedback from the general public and ask them, if that is what they were looking at originally in order to solve the problem. And if yes, then we'll have to proceed in that path. But if not, we definitely change our alternatives, or we come up with other mitigation measures based on the feedback of the stakeholders. We definitely develop a lot of algorithms. For instance, say we are looking at a widening project. Now, first up, you have different algorithms, for instance. Do you even need to widen that segment? If yes, you go on to the next step. If the answer is no right there, that's where your algorithm stops. So we go through this. This is an intensive exercise in every single step that we adopt in our day-to-day activities.
With the brand I'm in and with the rebrand that I've been working on the past year, I had to update our brand guidelines for the brand. So it gives anyone who comes in after me what fonts we use, what colors we use, how to use our fonts, what images to use, what images not to use, things like that. So it's a full, I think it's almost a 36-page book that I had to make. That breaks all that down. And one of the steps I put in there was, when we do show data, we like to do donut charts. So I found a really quick way to create them in Illustrator, and I put the steps for that in the book, so any designer that comes in after me will be able to keep the same look and feel for all the donut charts that we do moving forward.
So if I'm very familiar with the diagnosis, I have algorithms in my head from training, right? From things I have done ever since medical school. I've seen probably hundreds, maybe thousands of patients with similar diagnosis. And so I have an idea in my head of these are the drugs that work. I also try to do my best to stay up on the most recent data on problems, say like hypertension. We're trying very hard in medicine to be evidence-based, right? So when we do a study that tells us that X, Y, and Z treatment is 10% better than the one before, well, then we want to try and roll that out so that we follow the guidelines and say, okay, you came in with this problem, we're going to try this newer treatment, which is 10% more likely to get you better. And that type of thinking process is really a pattern, and that's all algorithms are, is this pattern of this is how we think about the problem, this is what we try and do to fix it, and if it works a little bit better, great, then we reiterate that.
In Unit 4, you'll continue to have the opportunity to demonstrate your learning using the micro-credentials. We also have some activities planned on human-centered design and algorithms, and I'm really excited to see all of the work that you create in the forums.